there to do?
According to the paper?
Every single problem you've done for me, haven't you guys just found a side? It's always find a side, find a side, find a side. Maybe add or subtract something onto it at the end, but it's always find a side. Can we use sine, cosine, and tangent to find an angle? Yes, and that's today. How do I find an angle using sine, cosine, and tangent? So let's take a look. I'm just going to dive right into the problem. Forget what's written up here. That's more of a, if you forget during homework, you can look back at it. So take a look at number 1. Now I'm giving you 2 of the sides. You know 2 of the sides. You don't need to find one. I want to know what that angle is now. Guys, I'm not changing the rules. Here we go. There's my acute angle I'm going to go from. X now. Identify what the 12 is. Identify what the 24 is. Same rules apply. What's the 12 and what's the 24? Here we go. Audrey. What's the 12 and the 24? You can pick either one first.
The 12 is adjacent and the 24 is the hypotenuse.
All right. Yeah. And according to what we've been talking about the last 3 days, if you have the adjacent and the hypotenuse side, you can use the cosine ratio. All right. So here we go. Cosine. What's my angle now? It's not an actual degree measure. I'm trying to find it. It's x. Cosine of x equal to adjacent side 12 over hypotenuse 24. Have I changed the thing yet from what we were used to? No. Now here's where it's going to change. Put those pens and stylus down right now because I'm about to do something that's incorrect. So most last 3 days have been, hey, it makes me feel warm and comfy inside when I put it over 1. Great, whatever. And then I cross multiply, right? I cross multiply. I get cosine x times 24 equal to 12, right? How are you going to get x by itself now? Silence. And there should be. Because you're not going to divide by cosine of 24 because there is no 24 degrees in the problem. So that's out. You can't divide by cosine 24 because there no such thing exists. You can divide by 24, and then what are you going to divide by? Cosine? Everyone see where we're stuck? Cross multiplying's not going to do it for me right now, is it? It's not going to do it for me. I need something else to find an angle now. And that is on your calculator. Everyone see, go back to your sine, cosine, tangent buttons. Do you see what is above them? Sine raised to the -1, cosine to the -1, and tangent to the -1. Those are called inverses. Inverses of sine, cosine, and tangent. That is what we need to find angles in a right triangle. So all this cross multiplying, not going to work when I find an angle. So just let me rewrite my equation. Cosine x equals 12 over 24. What we're going to need to do, ask the calculator, what angle x has a cosine ratio of 12 over 24? And the way we write that is now we do the inverse of cosine of 12 over 24. All right, so what we're about to do with the calculator is, hey, calculator, can you tell me the angle that has a cosine ratio of 12 over 24? So I go to my calculator, second cosine to get the inverse up, second cosine, 12 over 24. And it'll say, hey, 60 degrees has a cosine ratio of 12 over 24. So there is my angle. So to find an angle using sine, cosine, and tangent, we're going to have to use inverses now. All right, we're going to have to use inverses because I just proved to you guys cross multiplying ain't going to cut it here. All right, one doesn't make you great. Let's try another one out. On the second one here, still looking at angle x. Somebody identify what the 12 and the 18 is going to be here. What do you got for me? Kyla, what do you got? What is the 12 and the 18 here?
The 12 is the adjacent or the opposite angle, and the 18 is the hypotenuse.
All right. O and H. Now we use sine. Sine of x is now equal to 12 over 18. This is, again, I'm finding an angle. No cross multiplying. I'm finding an angle. Instead, I take the inverse of sine. What angle has a sine ratio of 12 over 18? Go back to your calculator again. Second sine. 12 over 18. Oh, what's it, nearest degree? About 42 degrees. All right, 42. There we go. All right. Yeah. I'm going to do a couple different versions of this coming up, but that's basically what I needed to get through to you guys today. Is we know how to find sides. We've done that a ton. Now let's find an angle. All right, so let's apply this to different types. Oh, anytime I can get a quadrilateral in there, I'm going to get it in there. Come on. Big unit for us. Big unit. Hij. Ki, that's a diagonal. 32 units. Kj, 11. Find angle IKJ. There we go. Do you see where the right triangle is? Right? Right. Rectangles have right angles. So J would be my right angle there. All right, going back to you guys. What's side 11 and what's side 32 for me? What sides do I have? Emma, going back to you. What sides do I have?
The adjacent and the hypotenuse.
Good work. So it looks like I can use cosine, everyone. Cosine. Cosine x equals adjacent 11 over 32 hypotenuse. And hey, let's say you forget and you're like, oh, I'm going to cross multiply. You're going to see pretty quickly, you're not going to know where to go if you cross multiply. Then hopefully that rings the bell. Oh, that's right. When I find an angle, I got to take the inverse of whatever ratio I'm working with. And to the nearest degree, what do I have for that angle right there? Nearest degree. 1,4. Let's go, Ellie. What do you got?
70 degrees.
70 degrees. Yes. Questions before I deliver some bad news? Questions? I'd apologize, but I wouldn't mean it. All right, I have a right triangle. I gave you one leg was 25 and the hypotenuse was 21 was the leg, 25 is the hypotenuse. It says solve. Anybody know what I'm going to have you do here? Yes, Omni?
Find all angle measures and all sides.
Anything that's missing, find it. Anything that's missing, all right? So when the directions say solve, because I believe you're going to see that maybe tonight on your homework, when the directions say solve, that means find any missing sides or angles. And I give you rounding directions for the sides and rounding directions for the angles. So I'm just letting you go at it. I don't want to pressure you and say, find the angle first. Find the side. You find whatever you want. Go. But I need to find I got one missing side and two missing angles you got to get for me. To go here, wherever you want to go. You let me know what you found first. Let's go, Omni. What do you want to do first?
The first thing I found was AC because I just did that.
All right, perfect. AC by using Pythagorean theorem. What did it look like?
It was 25 squared equals 21 squared plus x squared.
All right, everyone good? You could have done Pythag to find CA, and then to the nearest tenth, what do we end up with?
I got 13.6.
Yes, 13.6 feet. Got it. So there is AC, everyone. AC, make sure you check your work, 13.6 feet. Thank you, Omni. All right, what angle do you want to find now? What angle? Where do you want to go next? 1-9, here we go. Sean, what angle?
A.
Okay, angle A, how'd you get it?
A equals sine -1 times 21 over 25.
Okay, so you use sine, so let me just start from the beginning. Sine A equals opposite 21 over hypotenuse. And then he's like, all right, well, if I'm finding an angle, I got to take the inverse of sine. Good job. 21 over 25. And then what'd you get for angle A?
57 degrees.
57. Got it. All right, everyone good? All right, now I don't know if anybody noticed or not, to make your life a little easier, you did not have to do a ratio to find the second angle. Why not? You could have. I don't want to doubt. You could have did a ratio. Why did I not have to? Like in my case, I don't need to have ratio to find angle B. How can I get there instead? Quincy.
You can add the other two angles and then do 180 minus that.
Yep, I already have 2 out of the 3, and I know they add to 180. So 180 minus the 90 minus the 57 Sean just gave me. Everyone, angle B should end up being 33 degrees.
You need to show that first part that you have number 2 with the angle A over sine A.
What do you mean? I at least need to see this part, yes.
The angle A equals. I'm not sure I know what is supposed to. I only really showed the second part.
I at least need to see this first step here.
So what is?
I'm showing you that the sine of A is equal to the opposite side over the hypotenuse. If you show me the second step, I could do without.
Oh, sine A equals.
I'm just setting up. I'm just setting up what we usually set up.
No, I saw angle A over sine A there. I did not know.
Oh no, this is just angle A. Like I'm finding angle A. All right. Anything else? Yes, Ami. What's up?
So we have to show you like sine A equals 21 over 25. We can't just immediately go into A equals.
I would like to see that just to see where you started from. Now, if you go right from here to here, I'm okay with that. Okay, but I just want to see where you're starting from. All right. Last one. Got to always finish on a big Al. Boss. He's got a ladder now. He does everything. Walking across the pond. Using his ladder here. 18-foot ladder, 6 feet from the base of the house. All right. So a little right triangle action, right? Ladder leaning against the wall. It's an 18-foot ladder. Where's this 6 going to go? Because I feel like this is probably the hardest part of the whole unit, is actually drawing a diagram and putting the units where they appropriately belong. 6 feet from the base of the house. Where's the base of your house? Base of your house?
The bottom.
Bottom, right? Yep. 6 feet. And this always gives me a chuckle. Find the nearest degree the measure of the angle of the bottom of the ladder makes with the ground. Where is the ground located? And I'm saying this, jokingly, but people will put the angle up here, even though it says with the ground. Ground, your feet go on the ground, right? So it can't be there. Ground is on the bottom. So this is the angle we're looking for.
But what if Big Al is secretly Spider-Man? Then anything to do with the ground.
It's still the ground.
Still the ground.
Ground.
I don't care if you're Spider-Man or anybody. It's the ground.
Well, what defines ground? It's the thing you stand on. Does it have to be grass? Is it asphalt? It could be anything.
Oh, boy. All right, I'm just going to keep trucking. Oh, Zach, please help. Literally. 8. What's the 18 and the 6, Zach?
Cosine.
Easy, big boss. All right, stop showing off. I just wanted to know what the 6 and the 18 were. Adjacent, hypotenuse, opposite.
Oh,
Yeah.
18 is hypotenuse and 6 is adjacent.
All right, yep. Just trying to show off. Look at me. I know it's cosine. Cosine of x equals adjacent over hypotenuse. Good. And then, yes, as we've been doing all today, I'm going to take the inverse of cosine. 6 over 18. And what angle is that ladder making with the ground now? Finish on a good note. 15. Will, finish here, Will.
71 degrees.
71 degrees. All right. So here's what you have now. We got plenty of time. I gave you 15 minutes there. You guys have one problem on the next page and then a couple questions out of your textbook. That one problem on the next page deals with the rhombus. We did a problem yesterday with the rhombus. So if you need to go back and refresh your memory of the properties, that might be a good idea. All right, because you may need to remember your properties to do that problem involving the rhombus. And then once you do that one, hey, go to your textbook and get going. And as usual, let me know if you got questions. Reach out here. Reach out.